Let us look at two more examples of surface area of solid of revolution. First, let's take the example of a sphere. Now, surface area of the solid generated by a semicircle y is equal to square root of r square minus x square. So we have this semicircle. If we revolve it around the x-axis, we get a sphere. We have to figure out the surface area of this sphere. For revolution around the x-axis, in the previous session, we have arrived at this formula. So S is equal to 2 pi times the integral from a to b of y times the square root of 1 plus dy by dx square dx. So it's basically applying this formula to this context. Now here we require dy by dx. So let's differentiate y. So dy by dx is equal to 1 by 2 times r square minus x square to the power of minus half times minus 2x. Simplifying it, we get minus x by square root of r square minus x square. Here, a is equal to minus r. So this is the radius. So on the positive side, we have r, that is b equal to r, and on the negative side, we have minus r. So we have to figure out from a to b. Applying this formula, we get s is equal to 2 pi times the integral from minus r to r of y, that is square root of r square minus x square times the square root of 1 plus dy by dx is minus x by square root of r square minus x square square dx. Simplifying this, rest remains the same. Here we open up this square. We get x square by square root disappears, r square minus x square dx. Here we combine these two terms, we get r square minus x square plus x square by r square minus x square. X square minus x square, they cancel out. We are left with square root of r square by r square minus x square dx. Removing the square root, the numerator becomes r, denominator becomes square root of r square minus x square. Now here square root of r square minus x square, and in the denominator these two cancel out. So we have s is equal to 2 pi times the integral from minus r to r of r dx. Actually taking the integral, we get s is equal to 2 pi times integral of r is rx from minus r to r. Taking care of the limits, we get 2 pi times r, that is r square, minus r times minus r, that is minus r square, which is equal to 2 pi times 2r square. So the surface area of the sphere is equal to 4 pi r square. So this is the surface of area of a sphere. Now let's look at the other example. Now we are going to look at the surface area of the solid generated by the revolution of x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to a to the power of 2 by 3 above the x-axis. Now this equation gives us this curve. You will notice that this is symmetric across x-axis and y-axis. We will take the part of the curve in the first quadrant and revolve it. We get half the surface area of the entire thing. So which means we have to double it to get the complete surface. How does it look like, that surface? It looks like this. In polar form, the formula is S is equal to 2 pi times the integral from theta 1 to theta 2 of y times ds by d theta d theta. And ds by d theta is equal to square root of dx by d theta square plus dy by d theta square. So we require ds by d theta, but to get that we require dx by d theta and dy by d theta. Say x is equal to a times cos cube theta and y is equal to a times sine cube theta. Now, why this specific values? Interesting to figure out this. So I will leave it up to you to figure out why this specific values for x and y. We require dx by d theta. So dx by d theta is equal to 3a cos square theta times the derivative of cos theta, that is minus sine theta. So that is how this minus comes. Dy by d theta is equal to 3 times a times sine square theta times the derivative of sine theta, which is cos theta. Now, ds by d theta is equal to square root of dx by d theta square, that is minus 3a times cos square theta times sine theta square plus dy by d theta square, that is 3a times sine square theta cos theta square. Simplifying this by opening up this squares, we get 9a square times cos to the power of 4 theta times sine square theta plus 9a square times sine 4 theta times cos square theta. Now, here you will notice that 9a square is common, cos square theta is common, sine square theta is common. So let's take it out. We end up with ds by d theta is equal to square root of 9a square times sine square theta times cos square theta times cos square theta plus sine square theta. And cos square theta plus sine square theta is 1, so it disappears. We are left with ds by d theta is equal to square root of 9a square times sine square theta times cos square theta. Inside the square root, everything is a square. 9 is 3 square. So we remove square root and the squares to end up with ds by d theta is equal to 3a times sine theta cos theta. Now, ideally, I should have mentioned sine theta cos theta inside an absolute sign. But since in the interval that we are interested in, it is always positive, which means we can ignore the absolute sign. Now here, when x is equal to 0, what happens? We have a times cos cube theta equal to 0, which means cos cube theta is equal to 0, which means cos theta is equal to 0. And cos theta is equal to 0 when theta is equal to pi by 2. Again, when x equal to a, what happens? We end up with cos cube theta equal to 1. That means cos theta is equal to 1. Cos theta is equal to 1 when theta is equal to 0. So now applying this formula, we get s is equal to 4 pi times. Now from where did this 4 come? Remember, I mentioned that only the first quadrant part of the curve is being rotated. That means it will give the half the total surface. So that is why we are doubling this to get 4 pi times the integral from 0 to pi by 2 of y. Y is what? A sine cube theta times ds by d theta, which is 3a sine theta cos theta d theta. Now simplifying this, 3 we can take it out. So 3 times 4 is 12. We have a times a, which is a square, again which we take it out because it's a constant. So we have 12a square pi times the integral from 0 to pi by 2 of sine to the power of 4 theta times cos theta d theta. Now integrating, what do we get? We get sine to the power of 5 theta by 5. Now once you write this, just we can quickly verify whether it is correct or not. by differentiating this. Differentiating it, we get 5 sine to the power of 4 theta times cos theta. That 5 and 5 will cancel out. So we'll be left with sine 4 theta times cos theta. So that means this is correct. From 0 to pi by 2. Okay, now substituting the limits, what do we get? We get s is equal to 12a square pi times sine to the power of 5 pi by 2 by 5 minus sine to the power of 5 0 by 5. And evaluating this, what do we get? Sine 0 is 0. That means this term itself disappears. Here, sine pi by 2 is 1. So 1 to the power of 5 is 1. So we have 1 by 5. Which means we have 12a square pi by 5. So this is the surface area of this solid of revolution. Very interesting, right? Okay, so if you found this useful, please don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.